Okay, last question, which is question 10, photoelectric effect. Learners demonstrated the photoelectric effect by irradiating green and then blue light on a photo cell as shown. So this is the incident light, and then here we have now our metal. Okay, this is our metal plate, and then electrons move from the positive to the negative. Okay, okay. Then okay, we are told that a reading is registered on the ammeter when green light is used in the photo cell above. So it tells you if there is a reading here, it tells you that electrons were emitted. Okay, and then there was a current reading thereof. So why is this happening? It happens because now the what? The frequency of the green light is greater than the frequency. Actually, it's greater than the threshold frequency. Okay, the frequency of the incident light is greater than the frequency of the threshold frequency. In simple terms, you can say frequency of light. You can say, frequency of light is greater than threshold frequency, or energy of the incident light is greater than the work function, again, or a what is this? Photoelectric effect takes place, again, photoelectric takes place, again. These are the options that I can come with, again. And then, or you can say light of suitable frequency is used, however you English the off. Okay, but you should be in those lines. Okay, cool. And then 10.2, the green light is now replaced with a blue light of the same intensity and irradiates onto the photo thingy cell. What influence will this have on the following? The kinetic energy of the photoelectrons. Now let's compare. Voyager B. We need this. So initially they used blue, okay, green, and now they're using blue. Now frequency increases as you move that way. And then as you move opposite way, you are increasing the wavelength. So, okay, we want to know what will happen if I replace the green light with the blue light. Okay, so the question is, what influence will it have on the following, the kinetic energy of the photoelectrons? Will they increase, decrease, or remain the same? Well, the answer is, let's check. Blue, the frequency of blue is greater than the frequency of green. So it means this one. Okay, so it means blue will have a higher frequency. Okay, so if now blue has the higher frequency, remember that energy, it is equal to work function plus EK max. Let's say the energy of green was 10 and the work function is constant is 5. Then it means the EK max is going to be 5. Agreed. Yes. But let's use blue. Blue has a higher frequency, meaning higher energy. If this is 12, then can you see that my EK max is now going to be 7? If now my EK max is going to be 7, it means now the kinetic energy of the photoelectrons will increase. Okay? Will increase. Okay? The only thing that affects the kinetic energy of the photoelectrons, it is the change in frequency, and that frequency that you now use should be higher than the frequency you used before. Okay? Yes. And then They say, and remember, they're of the same intensity. Okay, same intensity. 10.22, the reading on ammeter. What influence will have on the reading on ammeter? Choose increase, decrease, or remain the same. Well, it will stay the same. Why? Check. I'm going to say, do you agree that they increased the frequency here? When you move from green to blue, you're increasing the frequency again. So you're going to say an increase in frequency only affects the kinetic energy of the photoelectrons. Okay? And then you need to tell us if this one affects the kinetic energy. Let me see. If this one only affects the kinetic energy of the photoelectrons, then what can affect the reading on ammeter A? We're going to say only an increase in intensity. Intensity increases the number of photoelectrons emitted per unit time. So if they increased the intensity instead, what happens when you increase the intensity is that more photoelectrons, okay, if you increase the intensity, it means you're increasing the number of photons. Remember, the frequency comes with photons. So we're increasing the number of what? Of photons. As you're increasing the number of photons, it means there are more electrons that you're going to be emitting with the same kinetic energy, though, if you are only increasing the intensity. So increasing the intensity only affects the number of electrons injected or emitted per unit time. So you're gonna take more electrons, okay? So if there are more electrons going to the current, so it means this one will shine brighter, okay? So that's what we refer to intensity, okay? So if there are more photoelectrons emitted per unit time, it means now there will be an increase in the intensity or the brightness of A with the same kinetic energy. Kinetic energy is only affected by the what? By the increase in frequency or change in frequency. I hope that's clear. Last question. They say the wavelength of the blue light used in the demonstration is 4.5 times lambda. Calculate the cutoff frequency or the threshold frequency of the metal that is used in the photocell if the average speed of the emitted photoelectrons is this. Okay, so E, it is equal to work function plus EK max. And now we are given what? A wavelength. So we know energy can be represented as Hc divided by this, okay? Because now we are rather given what? The wavelength. If we were given the frequency, we're going to just say it is HF. It is equal to, we want what? Calculate the threshold frequency. So this is going to be H multiplied by threshold frequency. You can also write this as Hc divided by threshold frequency. Can you see here? It will be threshold, but in this case, they want frequency. So, and then this is half mv squared max. It's just a matter of substitution. What is my H? 6.63. Is it 6.63? Or I'm using the one for, yeah, I think it is 6.63 times 10 to the power of 34. And then C, it is the speed of light, 3 times 10 to the power of 8, divided by the wavelength I'm given in meters, okay, which is 4.5 times 10 to the power of -7. It is in meters, it is good. and then 6.63 times 10 to the power of negative 34 multiplied by the threshold frequency plus half the mass of this. It is 9.11 times 10 to the power of negative 31, and then the voltage, so not the voltage, the speed, it is the speed, it is 4.62 times 10 to the power of 5, and you need to square that. And then you get that your F0, not F0, F threshold frequency, it is something like, when you punch your calculator there, you'll get it to be something like 5.2 times 10 to the power of 14 what? Hertz. Okay, hertz. So yeah, guys, that's that. That's that. Or you can say, let me calculate. Let me see if you are given, this is wavelength again. You can say, let me calculate the wavelength by using this one. You know that V is equal to, okay, and V in this case is going to be C. Okay, because we are using light, we are working with light. So V is going to be C. It is 3 times 10 to the power of 8 multiplied by F multiplied by 4.5 times 10 to the power of negative 7. And then you get F to be 3 times 10 to the power of 8. And then, okay, times 10 to the power of 8 divided by 4.5 times 10 to the power of negative 7. And then you'll get something like frequency to be 6.667 times 10 to the power of 14. You'd substitute it here and in HF. So it will be HF. It will be the same answer. So yeah, that's all, guys. And I hope you enjoyed the Gauteng preliminary exam question paper 2025. So yeah, thank you very much. Hopefully you'll meet me again on the chemistry paper, the same province, Gauteng. Good luck to those who are writing. Thank you.